Hi, we're in West Sacramento today. I'm Mark Fulmer for the Auto Channel, and as you can see, we're at the California Fuel Cell Partnership, and we're going to find out all about hydrogen as a fuel. Would you like to make your own hydrogen? This is how easy it is. You just take a little battery, put a couple of paper clips on it, put it in some salty water. You're looking at hydrogen. Could be the fuel of the future, all coming up right now on Road Trip. I'm joined by John Tillman with Volkswagen, and John is going to tell us all about how hydrogen, the most common element on this planet, can be combined with oxygen, probably the second most common element, to create electricity and to power our cars. Something like that, right, John?
Yes.
Okay. You're with Volkswagen, so I'll bet that we're going to take a road trip in a VW.
Yes, we're going to be taking out our Volkswagen Tiguan High Motion hydrogen fuel cell vehicle today.
Let's do it.
Yep, let's do it.
Okay, now what's the sound?
A fuel cell requires hydrogen and oxygen.
Right.
And the air compressor is actually what we use to pull in the oxygen from the air we breathe. The ratio of oxygen to other components in the air is about 20%, so about 5 to 1. 1 in 5 parts, should I say. So we need to push about 5 times, minimum of 5 times as much air through the stack as we do hydrogen. So
Okay.
the compressor's purpose is to push that oxygen through the stack to get the reaction to completion.
So if we're going to rob a bank, we better keep this running, right? Because otherwise we're going to be sitting here going...
Yeah, pretty much. You want to make sure, if you're going to have a getaway vehicle and a fuel cell car, you're going to want to keep it running, yeah. Okay.
I'd like to explode some myths about hydrogen itself.
Okay.
I think when you ask the person on the street, they might come up with, maybe a picture of the Hindenburg, exploding. And when I looked it up on the internet, I found out that there's a better chance that the aluminum oxide paint on the Hindenburg really caused the explosion. But hydrogen itself is a non-toxic gas, isn't it? I mean, we
Correct.
breathe it every day, and...
Hydrogen, the amount of hydrogen in the air we breathe is actually extremely small. It's infinitesimal, really. Nitrogen we breathe every day. That's actually a big component of air. But hydrogen, compared to gasoline, for example, the ignition points, the flammability points, the window of flammability for oxygen and hydrogen need oxygen to burn hydrogen.
Right.
It will not auto-ignite by itself without the presence of oxygen.
Yeah.
The window of flammability, although fairly large, it has a fairly high ignition point.
Yeah, the flammability, as I understood, was a little over 500 degrees for gasoline and over 900 degrees for hydrogen. So it's much less flammable,
Correct.
at least.
Correct.
Or 1/2.
And hydrogen also being extremely light. It actually is one of the lightest elements in the universe. And a single molecule of hydrogen, if it be released, has a velocity of about 40 miles per hour. It just goes straight up.
So it's 15 times lighter than air.
Yeah.
It's going to disperse. It's not just going to hang around
And it's
on
going to
the
disperse
ground.
very quickly. If I were to open up a kilogram of hydrogen tank, walk back 5 minutes later, I couldn't ignite what remains.
Yeah.
Unlike gasoline, if you get in an accident with a gasoline car, the gasoline that's there can be ignited an hour or 2 hours later. The vapors keep giving off, and you can actually ignite it.
It stores very well, too, doesn't it?
It does store very well. It is a very small molecule, extremely small. So you can't just necessarily put it in a metal tank like you do with welding tank bottles, for example, because you get what's called hydrogen embrittlement. The hydrogen will actually get itself within the pores of the metal and oxidize it. So you need you have special tanks, or at least tanks that are made of a special coating or lined material that you can store it at a high pressure to make
Carbon fiber. Huh.
Carbon fiber Kevlar actually is what we used with there's an aluminum liner.
Yeah.
Some tanks are actually also poly lined inside of the aluminum liner.
Okay, so a fuel cell. Now that we've kind of got a good idea of what hydrogen is about, a fuel cell really isn't a battery because it's continuously creating electricity by the combination of these two gases, right?
Yes.
And so a fuel cell for a vehicle or for, let's say, the space shuttle is made up of a lot of individual cells because each cell just makes a small amount of electricity, right?
Yes.
Okay. So the size of the fuel cell of the multiple fuel cells for this car would be about what size? Size of a suitcase or something?
Think of it as like one of those large Samsonite suitcases that you used to see around. It both looks very similar. They are about roughly the same size though. Physical size, giving you dimensions, I would say it's about 10 inches deep, 12 to 14 inches wide, and probably 30 inches long. Not really all that big. And that's for a fuel cell. In our vehicles, it puts out about 85,000 watts of power.
So a fuel cell sounds a little different than a pure electric or a hybrid car, doesn't it?
Very different. A pure electric vehicle really runs on batteries.
Right.
And the difference between the two, of course, as you mentioned, is that the fuel cell develops its own energy from the reaction of hydrogen and oxygen, dissociation of the hydrogen, freeing two electrons, and reassociation. You don't create electricity from the reassociation, you create it from the dissociation of the hydrogen.
Right.
But that is fundamentally different than a battery, of course, because when the fuel cell is just sitting, it's not doing anything. It's not creating, it's not storing energy. You can put your hands pretty much anywhere, you're not going to get shocked. A battery's whole purpose is to store energy.
If cars are your thing, if you're a gearhead, if you're buying a new car, all you need to know is the AutoChannel.com. With somewhere in the neighborhood of 1 million pages of content, the AutoChannel.com is the only automotive website you'll ever need to visit. Looking for the latest news in motorsports? Want to know what the hot new prototype was at the Detroit Auto Show? You'll know by going to the AutoChannel.com. The AutoChannel.com, your one-stop automotive website.
I just noticed something as you were accelerating. I noticed the acceleration. Have there been some changes in the last 5 or 6 years with this type of vehicle that now afford greater acceleration?
Well, electric motors haven't changed that much. I think maybe got a little more efficient, but how we control the electric motors has changed. The last few years, we've had a lot more ability to, with faster processors, to refine the control and to react a lot quicker, and then put different mathematics or different equations in there that allow us to control the acceleration a lot smoother. Early generation Priuses, for example, you'd see a little bit of a shudder. In early electric cars, you'd see a shudder because low power control of a high voltage electric motor was quite difficult. Now, it's not so difficult now.
Yeah, because the torque curve really isn't a curve. It's a torque plateau, isn't it?
Yeah,
you know, I mean,
it's a step change.
yeah. Have we gotten better in extracting hydrogen and in storing it in the last few years? Are there some? Is that becoming better and better?
We've gotten probably more efficient at producing it, at extracting it, the production of it from natural gas. Although industrially, natural gas is how hydrogen is produced. In any given year, we produce about 30 million cubic feet industrially already in the United States. So say we've gotten better at a process that's been around for a long time. I'm sure there have been improvements. But we've recently gotten a little better understanding of how to run electrolysis better. Basically that electrolysis is running a current through water to free the hydrogen and oxygen.
Yeah, which I showed that at the top of the show. And it seems to me a no-brainer that as solar energy gets better, you've got a real good way of making hydrogen.
It has a great potential of solar being renewable, of having a completely renewable fuel source from beginning to end. The one issue I see with that, of course, is the supply of water. Now, if you could use non-potable water or water that's sewer water, for example, which you definitely could, that won't be used or could never be used in any other application, possibly. But to use drinking water, I think in the large numbers of vehicles that could be in the road, it could potentially be a problem. But I think that
couldn't you use seawater?
You could use seawater, but of course you'd have the leftover salt.
Yeah.
And that has the potential actually to corrode or limit the electrical current that would run through the wire. So if you're going to use the salt anyway,
there's no cooking use for it or something.
Yeah. Well, there is for the salt. And if you just take put a electrolysis unit in the Bay of San Francisco, and you have plenty of available water. And then rather than using the salt beds, you just scrape the salt off of the electrodes.
Yeah. Well, how much don't we get a certain amount of pure water as the end product of this whole system? Yeah. So couldn't that be reused again?
It could be, but it's not a complete 100% generation of the water coming back. And the amount of energy, of course, the car you wouldn't want to do it. It wouldn't be very efficient to use the car's energy to electrolyze the water.
This isn't a very new technology, as I read up that it was discovered 120 years ago by a Welsh scientist, Sir William Grove, who put a couple of electrodes and combined the gases, and boom, got some current out of it. So after 120 years, it still is not only currently viable, but do you see it becoming more efficient over time as we start applying other technologies to it?
I'm talking about the fuel cell being more efficient, or actually the fuel cells in several manufacturers' cars are already becoming more and more efficient. Different manufacturers have stated they've got as much as 15, 20, 25% greater efficiencies over their own previous generations. So other companies are really starting to already tout their ability to produce a very efficient fuel cell stack. Honda, although I don't know the efficiency numbers they quoted, Honda has stated that they've got some extremely high efficiency numbers and seen as much as 10-20% improvements from generation to generation.
Now, I heard that the governor got involved recently, and why don't we take a short commercial break and come back and take a look at what Governor Schwarzenegger had to say about fuel cells.
Great.
Stick with us on Road Trip.
To some people, cars and trucks are everything. To others, they're just transportation. Whatever your interest level is, you'll find more at theautochannel.com. The Auto Channel has 1 million pages of content. No, I don't mean 1 million pages, I mean 1 million pages, including thousands of videos. And the Auto Channel has dozens of searchable databases with the latest new and used pricing information. And it's all free. Theautochannel.com. There's nothing else like it.
As you know, that we have made a commitment in 2006 to roll back our greenhouse gases to the 1990 level and reduce our greenhouse gases by 25%, and then an additional 85% by the year 2050. And the only way we're going to accomplish that is if we change the technology of our vehicles. And this is why I've, since the beginning of the year, brought here to the Capitol all kinds of different cars, from hybrid cars to hydrogen cars, electric cars, alternative fuel, biofuel, and so on. And this is, again, Volkswagen here has this Passat that was used in China during the Olympics. It has zero emissions. It's a hydrogen car, and you will hear more about the actual technology from Anna-Marie Schneider, who is here from Volkswagen. And I just want to congratulate Volkswagen for being out there and stepping up to the plate and meeting our challenges. And this is a partnership that comes from Shanghai, Volkswagen Shanghai, with the Chinese. They're working together on this. And then they're bringing now, I think, 17 over here to California, right?
22.
Or 22, actually, over here to California to test drive them. And then they will be importing them to California. So we're looking forward to that because, like I said, this is the only way we're going to solve our problem.
So, John, I noticed two things in that clip. I noticed you in the background, and I noticed that they were driving the Passats. Mm-hmm. Tell me a little bit about what was going on there.
Well, those Passats are actually part of our Chinese fuel cell fleet. Volkswagen has a really big presence in China, and we've had a project going on with Tongji University and a couple of other fuel cell device providers to basically evaluate and develop the technology on their own separate path. And we decided to bring them to the U.S. and drive them on the roads here and just see how they hold up. The driving patterns in Shanghai, or China specifically, are very different than the U.S. So we wanted to bring them here, really put them through their paces here. And the vehicles did very well. Unfortunately, they've now gone back to China. So today we brought out one of our German fuel cell vehicles, which is what you're riding in.
Well, what were the differences in driving experience? You mean just a lot more stop and go, or road conditions?
The road conditions are different. The amount of traffic in Shanghai. Shanghai is a city of 17 million people and a fairly densely packed area. And Sacramento, of course, is an area of around 400,000 people, plus the outlying areas. You can imagine the traffic issues and the road issues in everyday driving are very different. So we're able to really put a lot more miles in the cars in a short amount of time. And our roads are actually quite good, although their roads are pretty decent in China as well. And but we were able to really look at different kinds of driving, higher speeds for a more extended time. We were able to really go on country roads, where here country roads are still paved. They're really pretty decent. In Shanghai, I was told country roads are oftentimes not paved, so they would never take a car like that there.
John, I can't pull into a hydrogen station these days, but talk to us a little bit about infrastructure and where it sits and where it needs to be.
Okay, actually, it's not completely true that you cannot pull in. There are 2 stations, I think it's maybe 3 now, all Shell stations in the U.S. that you can actually pull up there at a commercial gas station. You drive up to the hydrogen-specific pump, you run your credit card, and you can get hydrogen. So you can actually, in a couple locations, get hydrogen now. The experience of it, though, the hydrogen is stored pre-pressurized in a storage tank on site at whatever kind of station it is. And you just fuel the car in about 5 to 7 minutes. For a car of this type, that gives us enough range for about 150, 160 miles. We do have vehicles that have over 200, 250 mile ranges. It's just the amount of hydrogen stored, not an effect at all of the fuel cell itself. Kind of a unique thing with hydrogen, you can produce it on site. You can produce it in your garage from natural gas that you already have for your stove, your heater. You can also produce it from water, as I mentioned before, electrolysis, again, at home in your garage. It's possible. It's not necessarily the cheapest way to do it or the most efficient, but it is something that many advocates of electric vehicles have touted for many years, that they can just go plug in their garage. Well, you can produce hydrogen in your garage as well. So there are ways around the distribution issue, or the chicken and egg question about what came first, the fuel or the car. And with hydrogen, you do have the ability to produce it. You can store it, you can truck it, and several of the ways are not necessarily the cheapest or the cleanest, but there are options for any problem that we've seen, such as a station far out in the middle of nowhere. There are options to get fuel to that station. And if you don't live near a station, again, you can put a production device in your garage at home. So there are ways around the issue.
If cars are your thing, if you're a gearhead, all you need to know is the AutoChannel.com. Looking for archival video of land speed racing on the Bonneville Salt Flats, Formula One at Nürburgring, drag racing at Pomona, Indy cars at Indy, or the Stalkers at Daytona, the only website where you'll find it all is the AutoChannel.com. With somewhere in the neighborhood of 1 million pages of content, the AutoChannel.com is the only automotive website you'll ever need to visit. The AutoChannel.com.
Whatever became of the concept of using hydrogen as a fuel in a combustion engine?
Well, actually, one manufacturer, maybe 2, several did experiment with it. One really went quite far with it and did burn it in a production car that could burn. It was dual fuel, could do gasoline or hydrogen. Unfortunately, that really is the least efficient way to use hydrogen. And the reason for that is, although hydrogen on a per kilogram basis is energy equivalent to a gallon of gasoline, when you combust it, the gasoline motor itself is not a very efficient device. It's about 18 to 26% maximum efficiency on the gasoline combustion engine. You take a low density fuel, you've got to push a lot of hydrogen in there, and then it combusts, but you combusted it again in a very inefficient way. And a lot of that energy that could have gone into the motion of the vehicle translates into heat.
Okay, now let's take it on the personal level, on the subjective level. I'm now driving a fuel cell car. How do I have to change my driving habits, or how I treat the car, the radio, the air conditioning, anything else? Are there changes do I have to adapt to the car, or does the car adapt to me?
None. Because of the fact that we actually develop or make our energy in the fuel cell as we need it, the fuel cell powers down at idle, which is about 1.5 kilowatts, using almost no hydrogen, and then basically pushes more hydrogen as needed. You're only using that hydrogen and therefore creating the energy when you need it. So if I were to step on the gas firmly, it would accelerate nicely, just like a gasoline vehicle would. Probably actually all the way up to full speed. You won't change gears, it just keeps accelerating at the same rate of acceleration. It doesn't peak out and curve in a curve over the top. Right now we're accelerating, we're going a little too fast.
You're in California, that's okay.
On the road I'm on, I'm going a little too fast.
There you go.
But as you noticed, there was no change in acceleration all the way up, and I let off the acceleration doing about 65 miles per hour.
John, give me a look at the economic picture. How much am I going to have to pay for this kind of technology, and will it pay me back? And what's the big picture economically for the user, for the buyer?
Well, Volkswagen has not, and since I work for Volkswagen, I can only speak specifically about what they've done with pricing. They have not set a price point on anything on a fuel cell system. It's still very much a prototype effort for us. We're really trying to evaluate the issues. Where are they? Where are we at? What do we need to do? What do we need to improve? But several OEMs have recently actually announced that they're going to be ready for production in as soon as 2015. And one OEM has specifically said at a price point that would shock people. To me, that price point means they're talking affordable. That vehicle is going to be affordable, which for a long time people say, oh, you can never make a fuel cell affordable. Well, that manufacturer has said in a very public way, we will have affordable cars, fuel cell vehicles, in 2015. So that says a lot about the affordability issue. Now, on a cost per mile basis, fuel cell vehicles, this SUV you're riding in now, it gets between 48 and 62 to 65 miles per gallon. That means that this vehicle gets between 2.5 to 3.5 times the mileage as the same gasoline version of this car. On same platform, same more or less weight. So your cost per mile for this could be, if you pay the same for a kilogram of hydrogen as you do a gallon of gasoline, your cost per mile would be 1/3 for this car as you would for a gasoline vehicle.
And don't we also have to factor in a really low maintenance cost, because you have a lot fewer moving parts?
The fuel cell itself has no moving parts. The balance of plant has a compressor, it has computers, it has humidification, it has water pumps, it has devices that do need maintenance, but there is no oil for the moving parts of the stack itself. So you're not going to change the oil every 3,000 miles. Your compressor might require, this particular one actually does require some lubrication, but we've actually never changed it, and this particular car has well over 5,000 miles. We've never actually changed the oil in that. So potentially, like a computer, if you have a diode or something go out, a capacitor, you don't go in and spend hours changing out that capacitor. You basically pull the board out, the electronic board out, you put a new one in, you go.
Well, John, thank you very much. This has been very enlightening.
Thank you.
Road Trip is a production of the Auto Channel.